Not so fast. It's not a blink. It takes time. Okay, so I'm going to copy the matrix one more time. And let's start. Do not put an equal symbol between matrices. They're not equal. So according to my sequence of steps, I have to get the 1 in the first entry, first row, first column. I did. By chance, it's there already. Now my next step is to get the corresponding zeros under that 1. I want this to disappear, and I want this to disappear. Obviously, I have to multiply this row by something and add it here to get the 0. I have to multiply row 1 by something else to add it here all the way, of course, to get 0 here. What should I multiply the first row by to get the 0 for 2 instead of 2 after I add the equations? So row 1 gets multiplied by something and added to row 2. Also row 1 gets multiplied by something else and added to row 3. So what should I multiply again? All this row by, so that when I add all this row here, I get 0 here. And then I get 0 here.
-2.
Exactly. That's how we did it in elimination method. Perfect. We will do that. But now what about for this? What should I multiply this row by in such a way that when I add this to this, I get 0?
1.
That's it. Now it's going to look differently, but it's exactly the same thing, but it's done in a condensed way. When I multiply row 1, I have to copy row 1. This is the only row that does not change. If I'm using it, it does not change. If you change the sequence of steps, you will never get the solution. This is carved in stone. 1 corresponding zeros, 1 corresponding zeros, 1 corresponding zeros. Don't be tempted. Okay, so.
That's an R, right?
Row okay. 1.
That's what I thought.
Yes. When we multiply row 1 by something, we'll have to copy it. Okay, so we multiply by -2 and we add it to row 2. On the side, top and below and above the arrow, we write what we do so we don't forget the operation. 1 multiplied by -2 and add it to 2. Answer.
Zero.
Perfect. -2 times -2.
4.
-1.
3.
Excellent. 2 times -2.
2, right?
+1.
3.
Excellent. 2 times -2.
-4.
+4.
8. Oh, 0. 0.
That's okay. Okay, excellent. Now we do the same thing for row 3, but with 1. 1 times 1 minus 1.
0.
Excellent. -2 times 1 plus 1. First, -2 times 1.
-3.
So -2 times 1 is -2 plus 1.
-3. -1.
Yes. -1 times 1.
1. 1.
-1.
-1 minus 2.
-3.
Perfect. 2 times 1.
2.
Minus 4.
-2.
What have we accomplished? Done. That's our accomplishment for now. So I finished with the first column. Where's my next step? This is my next step, because now I will be using this to get the zeros. Like I use this to get the zeros, now I will be using this to get the zeros. How do I get a 1 in here? And remember, we only have 3 operations. We can swap rows, we can multiply or divide any row by a non-zero number, and multiply, and that's exactly what we've been doing. So, is there a way of getting a 1 in here? This needs to be 1, because if it is not 1, I have difficulties getting the zeros up and down. Can I apply any of those operations that I'm allowed to apply in a matrix of a system that will make this, change this into a 1?
Do you divide by 3?
Divide row 2, both sides, everything, every entry by 3. Thank you. Good. So the first row stays as is. The last row stays as is. This cannot change. If I change this, I'm going backwards. This cannot. This is carved in stone now. So when I divide 3 by 3, what do I get?
1.
Perfect. When I divide 3 by 3, what do I get?
1.
And when I divide 0 by 3, what do I get?
Oh, there's
Excellent.
0.
Perfect. Good. So what have we accomplished? These and this. Now I want this to go away. And of course, I am at a stage in which I have to use row 2. Now I have to use row 2 and multiply by something to eliminate this. Multiply row 2 by something to eliminate this. We don't care about the rest. We are focusing on these 2 numbers now. So, what do I multiply 1 by to eliminate the negative 2?
2.
What do I multiply 1 to eliminate the negative 1?
1.
That's it. Which row I have to copy because I'm using it and it cannot change, other than this. This is carved in stone. Which row I have to copy? It must be row 2, because that's the row I'm using right now. Without the use of this to eliminate, I cannot eliminate these 2. So this is carved in stone for the moment. And this will always be carved in stone. I'm done with this column. 1 times 2 minus 2.
0.
1 times 2 minus 1.
1.
0 times 2, which is 0, plus 2.
2.
Right? 0 times 2 is 0, plus 2 is 2. 1 times 1 minus 1.
0. Negative.
1 times 1 minus 3.
Negative 3.
1 times 1 minus 3, right? Negative 2, correct? 0 times 1, which is 0, minus 2.
Negative 2.
Excellent. What have we accomplished? A lot. The page doesn't want to stay. We accomplished a lot. Where are we now? I want this one to become 1. What should I do to make this one to be a 1? We will
divide by -2.
divide row 3 by -2. I copy everything. The first 2 rows and the zeros. So -2 divided by -2, what do I write?
1.
-2 divided by -2 is also 1. Excellent. What have I accomplished? A lot. But what I want now is a 0 here and a 0 here, and I'm done. Obviously, I have to use row 3 and add it to row 1, and by another number, or maybe the same, and add it to row 2. And that will be the final step. So I multiply 1 by what to get 0 here, and by what to get 0 there?
1.
If I write 1 times 1 plus 1 will be 2, right?
Oh, yeah.
So
Will it be 0?
So it has to be -1.
-1.
Right. So we copy everything from the first 2 columns, the second column, and the 1 and 1. Because that was done. It's carved in stone. I can't change that. If it changes, then I go backwards and I don't solve. 1 times -1 plus row 1 plus 1. What do I have here at the top?
2. 1.
So 1 times -1 is -1 plus 1 is
2. 0.
perfect. So 1 times -1 and then plus 2. 1 times -1, it's multiplied, plus 2. One times -1 is -1, plus 2 is 1. 1 times -1 plus 1 is the same, 0. 1 times -1 is -1, plus 0 is -1. Can anyone give us the solution that this time is a triple? Not an ordered pair. Why? Because we have x, y, and z. It's not x comma y, but x comma y comma z. Can anyone from here read the solution of the system? We have no idea whether it's true or not. We assume we didn't make a mistake. We hope we didn't make a mistake. And of course, we will go back in a minute, 3 pages back, to the 4 pages back. I told you the first takes a while for me to explain. Here's the original system. I'll have to plug it in and make sure that that's correct. Can anyone dictate the solution for this one?
1, -1, and 1.
1, -1, and 1. Who knows if that's true? No one does, till we go back and check. Because x is 1, there is no z and y. Y is -1, there is no x and z. And z is 1, there is no x and y. So we claim 1, -1, 1. 1, -1, 1, 1, -1, 1, 1, -1, 1. I have no idea. Let's check. 1 plus 2 is 3. 3 minus 1 is 2. Yes, it is. 2 plus 1 is 3. Plus 1 is 4. Yes. -1 plus 1, this would be... Uh-oh. Oh, no, I'm sorry. -1, there is a minus in front. -1 minus 1 is -2, and minus 2 is indeed -4. My heart stopped for a moment, because I don't want to go back through all this and try to find the mistake or start from scratch. This is it. So I'll say, yes, I checked. It works. This is it. But of course, we need to practice. So I'm opening the book for another example. We don't have anything else from 6.1. This is it, but we need to practice this. And we don't have any other section from chapter 6 to go through. Okay, so let's look at 29. Would you like to choose? If you want to choose, please do. Page 631, or if not, I will. Okay, I thought 29 caught my eye. X plus 2y equals z minus 1. X equals 4 plus y minus z. And x plus y minus 3z equals negative 2. I'm checking I copied it correctly. X plus 2y equals z minus 1. Correct. X equals 4 plus y minus z. Correct. X plus y minus 3z equals negative 2. Correct. Let me put this away. Okay. First of all, I look at the system and I'll say, no, no way, no way. This is not arranged how it should be. So then I write x plus 2y. I bring z to the other side, subtracting z equals negative 1. That's okay. This one is another mess. I will bring y to the other side and z to the other side. Subtract y, but add z. So x minus y plus z equals 4. The last equation is fine. X plus y minus 3z equals negative 2. And now I can start the method. I will write the augmented matrix. Can anyone dictate the augmented matrix? Remember, we cleaned it up. It has to be in the correct order. X below x, y below y, z below z, and the free terms. Can anyone dictate the augmented matrix? But just tell me whether you dictate it by rows or by columns.
So by row is going to be 1, 2, negative 1, negative 1.
Awesome.
Then 1, negative 1, 1, 4.
Excellent.
And then 1, 1, negative 3, negative 2.
That's it. So from here, my first element is done. I have the 1. I can start getting the corresponding zeros. I need a 0 here, and I need a 0 here. Obviously, I have to use row 1 and add it to row 2, and row 1 and add it to row 3. What do I multiply all the row, but specifically 1 to get the 0 here, and this to get 0 here? In both cases, we multiply by
Negative 1.
everyone with me? Is this okay? Anyone? Everyone?
Yes.
Okay, so which row I have to copy, because it will not change right now.
First row.
Yes, of course, that's the one I'm using. 1, 2, negative 1, negative 1. So careful. 1 times negative 1 plus 1.
0.
Very good. 2 times negative 1 minus 1.
0.
So
Negative 3.
very good. Is that clear? 2 times
Yeah.
negative, okay. Negative 1 times negative 1 and plus 1.
2.
Excellent. Negative 1 times negative 1 and plus 4.
5.
Excellent. 1 times negative 1 plus 1.
2.
We want a 0, right? So 1
Oh,
times
yeah.
1 times negative 1 plus 1 will be
1 times negative 1 would be negative 1.
yes, and then plus 1.
0.
Perfect. 2 times negative 1 plus 1?
-1.
Excellent. -1 times -1 minus 3.
-2.
Excellent. -1 times -1 minus 2.
-1.
Excellent. Great job. So we accomplished a lot. Now I want a 1 in here. But if I want a 1 in here, I should divide, but I don't want to. I'll have a lot of fractions. Is there another option here? If I don't want to divide like we did in the previous example by -3, because if I do, then this is -2/3 and this is -5/3. Is there another option looking at this number? But I can change this because this is carved in stone. So this cannot be changed. These two cannot be changed. This row and this column are fixed now. But is there any other way that I could get a 1 in there without having to divide this row?
Swap.
So I will swap. So I will write that row 2 now becomes row 3 and row 3 becomes row 2. I write it on the side so I know what I did. So I copy the first row, which cannot change. I copy now this third row, and then I copy the second row. Because in order to get a 1 in here is very easy now. How do I get a 1 in here? This piece, this entry has to become a 1.
Multiplied by -1.
Row 2 multiplied by -1. Great job. I copy row 1. I copy row 3. And can anyone tell us what to write for row 2? Obviously 0, this is carved in stone for the rest of the problem. That cannot change. Nothing there can change.
It'll be 1, 2, 1.
Yes, 1, 2, 1. -1 times -1 is 1. -2 times -1 is 2. -1 times -1 is 1. Excellent. So we accomplished the 1. It's done. My next step is here. These have to go away. Which row do I use now to make the 2 and the -3 go away?
Let it be row 3.
I'm not with row 3. I have to get a 1 here, but I'm not there yet,
Okay.
right? So the first step is always row 1. The second step is always row 2. I meant to write R. And the last step is always row 3. Good. So 1 should be multiplied by what to get a 0? And 1 should be multiplied by what to get a 0?